Imagine looking at two particles on opposite sides of the universe and watching them dance in perfect synchronization, instantly mirroring each other's moves despite being separated by billions of light years. No signals, no delay, just impossible coordination that defies everything we know about reality. This is quantum entanglement, and today, we're going to explore what it would look like if your eyes could actually see this bizarre phenomenon that Einstein himself called spooky action at a distance. What you're about to discover will fundamentally change how you view the fabric of reality itself. Quantum entanglement is one of the strangest phenomena in all of physics. When two particles become entangled, they form a connection that transcends space and time. Measure one particle's property, and you instantly know the corresponding property of its partner, regardless of the distance between them. Scientists have experimentally verified this over distances exceeding 1,200 kilometers. But here's the thing. We can't actually see this happening with our naked eyes because it occurs at the quantum scale, far below what human vision can detect. So what would it look like if we could see quantum entanglement? Picture this. You're standing in a room with two glowing spheres hovering in midair. These aren't ordinary spheres. They're visual representations of entangled photons, magnified billions of times so you can observe them. At first glance, they appear to be pulsing with a soft, ethereal light, cycling through different colors. But here's where it gets wild. The moment you observe one sphere closely, watching it settle into a specific color, say blue, you see something incredible happen. The other sphere, perhaps sitting across the room or even across the galaxy in our thought experiment, instantaneously shifts to a corresponding state. Not blue, but maybe red, depending on their entangled relationship. There's no wave of light traveling between them, no signal you can trace. The change is absolutely instantaneous. The visual effect would be mesmerizing and deeply unsettling. Imagine thin, shimmering threads of probability connecting the two particles, like gossamer strands of spider silk made of pure mathematics. These threads wouldn't exist in normal three-dimensional space. Instead, they'd phase in and out of visibility, existing in a superposition of being there and not being there simultaneously. When you're not looking directly at either particle, both spheres would appear fuzzy, indistinct, existing in all possible states at once, a blur of every color simultaneously. They'd shimmer with potential, undefined and indefinable. If you've been fascinated by the strange nature of quantum reality so far, do me a favor and hit that like button and subscribe to the channel because we're diving deep into mind-bending science that'll make you question everything you think you know about the universe. Trust me, you won't want to miss what's coming next. Now, let's take this visualization further. What if you could see entanglement happening in real time throughout the universe? Your enhanced quantum vision would reveal an invisible web connecting countless particles across the cosmos. The universe would transform before your eyes into an incomprehensibly complex tapestry of glowing connections. Every atom that ever interacted and became entangled would show a faint luminous thread stretching across space. The Big Bang entangled countless particles, so you'd see connections reaching back 13.8 billion years across the observable universe. The night sky would look completely different. Instead of seeing stars as isolated points of light, you'd see them embedded in a cosmic neural network, with entangled particles creating a web that makes the entire universe look like a single interconnected brain. Galaxies wouldn't be separate entities, but nodes in an incomprehensibly vast information network. Every black hole, every supernova, every collision between particles in a distant nebula would send ripples through this quantum web, creating cascading patterns of correlated change. Here on Earth, the view would be equally spectacular. Every particle in your body has likely been entangled with particles elsewhere at some point in its history. You'd see threads of quantum correlation extending from your hand to distant stars, to particles in the ocean, to atoms in ancient rocks. You wouldn't be an isolated being, but a nexus point in a universal quantum network. When you'd touch another person, you'd see new entanglements forming in real time, creating fresh connections that would persist even after you separated. But perhaps the most profound thing you'd witness would be the act of measurement itself. In quantum mechanics, observation isn't passive. It's an active process that collapses probability waves into definite states. If you could see this, you'd watch those shimmering, undefined particles snap into sharp focus the moment you truly observe them. The infinite possibilities would cascade down into a single reality, and you'd see the exact instant when potential becomes actual. You'd be watching the universe make decisions and witnessing the moment when the indefinite becomes definite. The philosophical implications would hit you immediately. You'd see directly that reality isn't predetermined, that the universe exists in a state of probability until observation forces it to choose. You'd understand viscerally why quantum mechanics challenges our notions of locality and realism. The universe isn't made of things in places. It's made of relationships, connections, and correlations. Separation would reveal itself as an illusion. Everything would be demonstrably interconnected at the most fundamental level. Scientists are actually working on ways to observe quantum effects at larger scales. While we can't see individual entangled particles with our eyes, researchers have created quantum states in increasingly large objects. Who knows? Perhaps one day, technology will allow us to visualize these quantum connections in ways that approximate what we've imagined today. The universe is far stranger and more beautiful than our everyday experience suggests. Quantum entanglement reveals that reality is fundamentally non-local, that separation is provisional, and that everything in existence is woven together in ways that transcend our intuitive understanding of space and time. If this journey into quantum reality has expanded your mind, make sure you're subscribed to the channel and hit that notification bell so you never miss our explorations into the most fascinating mysteries of science and the universe. Drop a comment below telling me what aspect of quantum mechanics you'd like to see visualized next. Thanks for watching, and remember, reality is far weirder than you ever imagined.